All right, folks, back at it again. We are starting chapter 5. I know that seems like a jump for you probably, but we are going to chapter 5, which is where we start all our trigonometry. We're going to be doing trigonometry for a while. We're going to do chapter 5, then chapter 6, then chapter 7, right in order. It's basically everything I might say you didn't want to know about trigonometry. It's trigonometry through and through. You're going to learn everything right from the beginning forward. And today's going to start that. We're going to start with 5-1. So let's get right to work. Let's go here. And when we're here, I want to make sure I'm in the right color. All right, so we have 5-1. And this is angles in degree measure. So it's going to be a lot of basics, but it's all stuff that I think it's so basic. Some of it you forgot and some you never learned. So there's some of the things in here that are kind of new. So you want to pay attention and make sure you get everything in here. And I'm just going to go through examples because I think it's the easiest way to learn or relearn this stuff. First off, first example, they're going to say change each measure to degrees, minutes, and seconds. So if right off the bat I lost you because you said, all right, you were going to talk to me about degrees and angle measure and all that, and now all of a sudden you're talking about time, minutes and seconds. We need to talk about that for just a moment. When we talk about changing a measure of degrees, and I'm going to give you something like this, where we're going to say, let's say 27.855 degrees. And we want to change this to degrees, minutes, and seconds. The idea here is this. When the system of 360 degrees creates a circle, that was all based off a base 60 sort of base 60 measurement system. And everything was off 60s. So when we talk about 360 around a circle, but a lot of this was used for navigation. And if you start talking about 1 degree difference over hundreds of miles, you can be far off course. So they wanted to get a little bit finer than just breaking it into 360 degrees. They wanted to say how much more accurate could we be? And decimals are good, but they're not base 60. So to stay with the base 60 idea, what they said is let's take each degree, each slice of that circle that goes around, and break that into 60 more pieces. And so if you think of a clock face, you have a whole circle around. If you take 1/60th of it, it's a minute, right? And then they said, what even finer, more kind of accuracy, we could cut each of those minutes into 60 seconds. So that's what they're saying here is they want to talk about minutes and seconds beyond the degrees. So what's going to happen is this is going to stay the same. It's going to be 27 degrees. When we change it over, it's still going to be 27 degrees. So we'll have that. But now we have to add how many minutes and seconds this part represents. All right. And it starts out pretty basic because the first division is minutes. Well, it's 60 minutes that make a degree. This is 0.855 of that. So all you would do to find minutes is take your decimal and multiply it by your decimal, I mean this, and multiply it by 60. So for us, that would look like this. I would say 0.855 times 60 equals what? So this is going to be calculator stuff. You do 0.855 times 60, and you get 51.3. So what does that tell me? Well, that's 51.3 minutes. So what I'm going to do is take that number and put it up here as the minutes, not the whole thing, because I want whole minutes. So it's 51 minutes, and we use a single dash, kind of like feet, right? But it's now minutes. And then we say we still got 0.3 minutes. So how do we change minutes to seconds? Because we want the fraction of minutes. A fraction of a minute is a second. So we get seconds by doing this. by saying we had 0.3 minutes. So we take our decimal of minutes, and maybe I should mention that this is decimal of degrees, right? This is decimal of minutes. We take that decimal and multiply it by 60, and that'll tell us how many seconds. So I do 0.3 times 60, and you end up with 18, right? So you end up with 18 here. And that would be from degrees, minutes to seconds. From degrees as a decimal to minutes and seconds, we would do that. Now, if this came out a decimal, say that when we did our seconds, it came out to 18.3, you just round it. We can't get any finer than seconds. So when you get to the seconds part, if there's still a decimal, when you did this multiplication, then you just leave it as you round it appropriately, okay? So that's the first thing we're going to be asked to do, is they're going to ask you to do things of that sort. All right, so let's keep going, get to the next type of problem. Now, if we go the one direction, we got to be able to go the other. So now let's go, instead of from the minutes and seconds, or from degree to minutes and seconds, let's go minutes and seconds. And now let's take that to degrees as a decimal. All right, so let's think about how we can do that. So let's get another example. Let's say we're starting with something like, let's say 32 degrees, 14 minutes, 26 seconds. So how am I going to change that? Well, think of what we're given here. This is going to stay the same. The 32 degrees is still 32 degrees. It's going to be, what we're going to do is change this into 32 point some degrees. So how do we find that decimal? Well, we take this first piece. So let's take this piece, 14 minutes. What is that? 14 minutes out of 60. So we find out what this represents as a decimal, right? So 14 out of 60 is going to be 0.233 repeating. So I'll go to 4 decimals because we want to do this to 3 decimal accuracy. So let's go 4 decimals here, and we'll round at the end. So we got this as our first decimal. I say that that's representing the minutes, which are 0.233 repeating degree part. That's the portion of a degree. It's 0.2333 degrees is 14 minutes. Make sense? Hopefully. All right, so now the 26 seconds. Well, 26 seconds of a degree is, again, there's 60 minutes in each degree and 60 seconds in each minute. So every second is 1/3600th. In other words, 60 times 60, right? There's 60 seconds times 60 minutes, or 3,600 seconds in a degree. So this is 26/3600ths in terms of the decimal of degrees that it is. So we need to know that number, 26 divided by 3,600. And that would be 0.00722. And now we need to add these two together. All right, so we're going to go down here and we're going to say, what is 0.2333 plus 0.0072? And just going 4 digits is enough, because we're going to look at that, and it would come out to 0.2405. I would accept 0.24. Honestly, with a 0.5, I'd accept 0.241 or 0.2405. I think it's easiest just to write it out to 4 decimals here, or 4 digits past the decimal, I guess is the correct way to say that. And these are in degrees now. So this would be our solution. All right. So again, I don't think it's that complicated, but you got to remember the process and understand the relationship. Minutes are 1/60th of a degree. Seconds are 1/3600th of a degree, right? Or 1/60th of a minute is the seconds. So same idea. All right. So we can go back and forth that way. So now, this I think is more straightforward, the next thing. And they're going to ask you again, I'm just giving you a bunch of examples, guys, because these things are things I think you kind of knew some of them you didn't, but I think it's easier to see them instead of going into the theory behind it. I think it's easier for me to just give you the examples of what we're going to be doing. and you'll see how we use it in the next few sections. All right. All right, so now it says give the angle measure represented by, I'll say, each rotation. And they're going to tell you something like, let's say 3.2 rotations. And let's do clockwise. All right, so we need to talk about this idea of clockwise versus counterclockwise. All right, we all kind of have an idea of how a clock works. If a clock, the hands rotate around from the top, they would go to the right, around to the bottom, and up to the left. So this is a clockwise rotation. And counterclockwise, of course, would go in the opposite direction. Okay. Now, when we're talking about this in terms of degree measures, we consider every standard position angle, and that's another new term. A standard position angle starts out on the positive x-axis. This is where its initial side would be. All right. So a standard position, and I'll just abbreviate this, a standard position angle has its initial side on the positive x-axis. When we rotate a standard position angle from here, it rotates counterclockwise, and this is considered a positive rotation. All right, clockwise is considered a negative rotation. So positive rotation for a standard position, initial side here. And we also have, say that this angle terminates here. We call this the terminal side. All right, we have initial and we have terminal side. All right, so if this angle came around to here, it would be a positive rotation from its initial position and standard position, where its initial side is on the positive x-axis, rotating counterclockwise, and it would have a terminal side here, and we'd have some angle measure. All right, so when I say clockwise, I'm actually talking a negative rotation. So the first thing you see is when you see clockwise, you should think this answer is going to be a negative number of degrees. Now, 3.2 rotations, how much is it to go completely around in a circle in terms of degrees? It says give the angle measure. When we talk an angle measure, we're talking degrees here, right? So how many degrees is it to go around one full rotation? That would be 360 degrees. So what we do to find this degree measure is we take 360 degrees. Get used to making your degree symbols on everything that's a degree, folks, because we're going to be using radians later in this chapter too. And I'm going to multiply it by 3.2. So when I say 360 times 3.2 rotations, because each rotation is 360, I would end up with 1152 degrees, negative 1152 degrees as my rotation. That would be the same in the angle measure represented by this 3.2 rotations clockwise. Okay, so there's one example. So if I ask you 5.6 rotations counterclockwise, well, counterclockwise now is a positive rotation, right? We just talked about that over to the right here. Counterclockwise is a positive rotation. So 5.6 rotations, we do the same thing. We do 360 times 5.6, and we get 2016. It's a good year, pre-COVID, right? So 2016 degrees, and that's positive. So I just write it as 2016 degrees. And that would be that solution. So again, introducing some new concepts in terms of the words that we're using. An initial side, standard position angle, right? Standard position angle starts on the positive x-axis with its initial side. It rotates counterclockwise. If it's rotating positive direction, it's rotating counterclockwise, and until it hits its terminal side. Okay. So that's one new concept. So when we get a standard position angle, and I'll be a little fancy here, let's get an axis. If I have a nice axis here, and we talk about an angle that's in standard position, to write this out a little bit bigger this time because we're going to delve into this a little deeper than what I did in the previous page. All right, a standard position angle. Again, that means this is its initial site. It's here. Its vertex, to go even deeper, is at the origin. So vertex at the origin, initial site on the positive x-axis. If it's rotating positively, it's going in this direction. So now when I talk about its terminal side, let's place one in here. Let's say I have a terminal side here, like I talked about in the last page. And so our rotation is this way. And let's say this rotation is 122 degrees. All right. So this is a 122 degree standard position angle. And what they may ask you is find all coterminal. This is another new term. No pun intended because it's got term in it. Find all coterminal, and I'm just going to abbreviate and say angles. Find all coterminal angles to the angle given. Well, let's think about this. If I want coterminal angles, you got to know what those are first. So a coterminal angle is an angle that terminates at the same place as the angle you're given. So if I want to look at this and say what other angles would terminate there? Well, think about it. If I start here, standard position angles we're talking about, and I go past this and I keep going past it and come all the way back around, isn't this angle terminating in the same place? It'll look the same, but it has one full rotation extra. So if we add one full rotation to this, we get another angle that terminates here. So how would I do that mathematically? Well, I would say 122 degrees plus another 360 degrees would give me another coterminal angle. So that would be, what would that, 482 degrees would be a coterminal angle. Now, I could also go in the opposite direction. If I started here and it said a standard position angle, a coterminal, I could go this direction and this still terminates at the same place. And how would I find that one? This one now is going negative, right? And it's, if you think about it, it's one rotation back from where we started terminally here. So how do I find this? Well, think about what's happening. Aren't I just going 360 in the other direction? So if I took 122 degrees minus 360 degrees, what would I get? You get a negative 238. So negative 238 degrees would also be coterminal with this. And now I could do this infinitely, couldn't I? Going in the yellow direction, I did one rotation and back to my terminal side. I could go a second rotation. We just keep adding 360 or keep subtracting 360 and I would get more coterminal angles. So when it says find all coterminal angles, the way I do that when I want to find, let me get something that'll stand out here. When I want to find all coterminal angles, I have to have a general expression. Well, it looks like what I'm doing is taking my initial value and then I'm saying plus or minus 360 degrees K. That would, when I say K, I'm saying K is any integer. And you have to note this. This is the most common error people make is they forget to write K is any integer. Because I'm not talking about 1.5 times 360. I'm talking about 1, 2, or negative 1, 2, 3. So K is any integer. And honestly, I could say 122 degrees plus 360K. K is any integer because integers are both positive and negative. And probably, I mean, that's correct too. But you'll see more often that people write plus or minus 360 degrees K, where K is any integer. All right, so this would be a way of describing all of those. You take the original angle, add or subtract 360 degrees, and you've got all of them. Now, if it says find one positive and one negative, this sometimes happens where they say find one positive and one negative coterminal angle. Well, again, I could have used these two, couldn't I? That's a positive one. That's a negative one. There's infinitely many answers to this, but that's one positive and one negative. So let's see if you can do this. If I gave you let's say 712 degree, or since I wrote 7.2, I'll say 722 degree standard position angle, and said find one positive and one negative coterminal. Well, I can do either one. I can do 722 degrees plus 360 degrees would give me, what would that be? 722 plus 360 is 1,082. So that would be 1,082 degrees. That is one positive coterminal. Now I could also do 722 degrees minus 360 degrees. And that would be 722 minus is 362, right? So 362 degrees. Now that's another positive one, but it wants one positive, one negative. So I could have used either one of these, right? Either one of these for my positive answer, but I still need a negative. So let's do 722 times, or 362. Let's start at that one and subtract another 360 degrees. And that would get me down to 2 degrees. 2 degrees, still positive, right? So I've got 3 different ones I could use for positive, but let's keep going. 2 degrees minus 360 degrees. That equals a negative 358 degrees. I finally have a negative coterminal angle. So I could use this one for negative and any of these other 3 for positive ones. All right, that's the idea of coterminal angle. It terminates at the same place, meaning it's a rotation forward or backward, clockwise or counterclockwise from the original terminal side. All right, and you just add or subtract 360 until you get that. All right, so they may also ask you with these, where does the terminal side lie? What quadrant? So if they ask you about the quadrants, remember your quadrants are these things. First quadrant, we usually use Roman numerals. Second quadrant, third quadrant, and fourth quadrant. So when I told you my first one was 122 degrees, that was a second quadrant. The terminal side was in the second quadrant. What about 722 degrees? 722 would be around twice and then back here at 2 degrees. So it would be in the first quadrant. So if they ask you to state the quadrant in which the terminal side lies, just find where the terminal side is. And just by doing rotations, you can make yourself a little sketch and find where it terminates. All right. Now, this idea of where the terminal side is important because the final thing we're going to talk about is one of them that we're going to use continually. And that is the idea of a reference angle. All right. A reference angle is the idea that when we start to talk about, I'm going to look at drawing an axis again here so we can deal with a angle. All right, so I draw a standard position angle on this axis. All right, so I've got this standard position angle if it's here. All right, what we do, well, that's just so ugly. Let me get rid of that, guys. I'm going to do it nice. All right, if we have a standard position angle, meaning it has its initial side here, and let's say its terminal side, let's do something a little different. I'm going to do it this way. Its terminal side is here. Anywhere in this first quadrant, you've got a terminal side here. When we talk about the reference angle is the angle, the easiest way I can describe it to you is the angle the terminal side makes. I want to write this all out. The terminal side makes with the nearest x-axis. All right, so when I look at this angle in standard position, this is the angle. The angle it makes with the nearest x-axis is this angle. This is the closest thing to it. If I try to go to this side of the x-axis, by the nearest x-axis, I mean it's either this side or that side. If I go over here, that's not as near, not as close as this one. So this angle, whatever this angle is its own reference angle. If this was, say, 72 degrees, the reference angle here would be 72 degrees. All right. If instead we have and I'll do this in a different color, we have a standard position angle there at that point. And let's use the same color. So I have this other standard position angle that is in the second quadrant. It's over here. Well, now that one, this is the angle. Let's say this angle is 130 degrees. All right, this angle terminates in the second quadrant. Its terminal side lies in the second quadrant. The angle it makes with the nearest x-axis, its reference angle would be this angle. How do I figure that out? Well, we know going halfway around is 180 degrees. If I've already gone 130, then this would leave 50 degrees here. So its reference angle is 50 degrees. When I say the nearest x-axis, what you're going to find is the reference angle is always a first quadrant angle. It's an angle between 0 and 90, and it's always positive. Even though you see me go in this direction, we consider it a positive. The reference angle we consider as a positive. It's kind of like an absolute value. It's a distance. So that reference angle is 50 degrees. Reference angle in first quadrant for this one, 72 degrees, was 72 degrees. This was a 130 degree angle, 50 degree reference angle. All right, these are going to become very important to us later on. All right, so let's look at another one. Let's go to a third quadrant angle, and let's use another color. So here, if I have this angle, that again, initial side here. Whoops, gotta go back here, sorry. Its initial side on the x-axis, and its terminal side is over here in the third quadrant. So it's right here. And again, that means this angle, oh, I didn't want that color. Sorry. Its angle is going all the way around here. That's really ugly, but you get the idea. Let's say this is a 262 degree angle. This one is 262 degrees. Now let's put that in the quadrant with it so we can see it. So 262 degree angle. Its reference angle would be the angle it makes with the nearest x-axis. That's this one. So how would I figure that? Well, again, I know coming around to here is 180, and then I went in extra how much? Well, 262 minus 180, right? 262 degrees minus 180 degrees would give me this difference, wouldn't it? So that would be 82 degrees. Reference angle here for this one would be 82 degrees. Again, positive. It's a positive 82 degrees. All right, and finally, we have the only quadrant we haven't dealt with yet. If we go to the fourth quadrant, again, standard position angle. I forgot I didn't do my line thing here. And we go into this quadrant. Let's say we're here. So now we have an angle that's going all the way around. This is going to be ugly, but you get the idea. It goes all the way around to here. And that angle is 310 degrees. All right. So we've got a 310 degree angle. The angle, and let me just write that on the other side again. So 310 degree angle. The angle it makes with the nearest x-axis would be the angle to this axis. So how do I figure that? Well, we know all the way around is 360, so 360 minus 310 will give me my reference angle. This has a reference angle of 50 degrees. All right, this idea of a reference angle is going to become critical. It's something you have to have in your vocabulary. So that's it. That's what we're going to be doing with this section. They're going to be giving you a lot of different questions on these. They're kind of basic mathematically in terms of what they're asking you to do, add, subtract, multiply, but they are conceptually pretty strong, and they're going to use them throughout this chapter and pretty much every chapter after this. So you want to be able to understand these relationships as we switch from degrees to radians and things of that sort. So make sure you commit these words to memory. You're going to need to be able to read questions that involve these words and understand what they're asking you to give as an answer. That's where a lot of students will fall apart on this, is they learn it as a matching sense. You start to learn it as, all right, I see this, I should do this. And then when they get to the test and they see the word description of the problem, They don't know which one it's asking for. So make sure you know what the words mean. All right. And that's it for 5-1. That's our intro, our beginning, first baby steps into trigonometry. So have a wonderful day, and I will see you all real soon.